Golf. Invented in Scotland as a way to waste precious land, golf is now one of the most popular sports in the world. Golf may look like a simple swing of a club, but behind every shot is a complex combination of physics, kinematics, forces, energy, momentum, and projectile motion. In this video, we'll break down the physics behind the golf swing and ball flight, showing how understanding these concepts can help golfers hit farther, straighter, and more efficiently.
We'll start with the basics. Kinematics. Kinematics is the physics of motion. It describes how objects move without worrying about the forces that make them move. First, let's look at speed. Speed is simply the distance an object travels divided by the time it takes. For example, if a golf ball travels 40 meters in 4 seconds, its speed is 10 meters per second. There are two types of speed: instantaneous speed, which is the speed at any given moment, and average speed, which is the total distance divided by the total time. Velocity is similar to speed, but it also includes direction. It's a vector quantity. So if a ball travels 10 meters per second, that's its speed. But if it travels 10 meters per second north, that's its velocity. Any change in speed or direction will cause a change in velocity. The rate at which velocity changes is acceleration. Acceleration equals the change in velocity divided by the time. For example, if a ball has an acceleration of 10 meters per second squared, that means every second its speed increases by 10 meters per second. So if the ball starts at 0 meters per second, after 10 seconds, its velocity would be 100 meters a second. Another important concept is displacement. Displacement is the change in an object's position. In other words, how far it has moved from its starting point, taking direction into account. In golf, we're interested in the ball's displacement to see how far and in what direction it travels after being hit.
Let's take a more in-depth analysis of motion. This includes projectile motion and freefall. For this project, we'll be neglecting air resistance. Firstly, we'll define scalar and vector quantities. Scalar quantities only consider magnitude, while vector quantities consider both direction and magnitude. Motion can be split up into two components: horizontal motion and vertical motion. These components act independent from each other. However, their vector sum, or also known as resultant, will show a single vector that represents the combined net magnitude and direction of both components. The vector sum shows the true direction of an object. Freefall can be defined as when a falling object only has gravity acting upon it, ignoring things like air resistance and friction. In golf physics, we are often concerned with range, which is the horizontal distance a projectile travels from launch to landing at the same height. In ideal projectile motion with no air resistance, the range is given by r equals velocity squared sin 2 theta over gravity. Under these conditions, a launch angle of 45 degrees maximizes range because it balances the horizontal and vertical components of velocity.
First, what is inertia? Inertia is an object's tendency to resist changes in motion, as described by Newton's first law. This law states that an object at rest stays at rest and an object in motion stays in motion at a constant speed and direction unless acted upon by a net external force. A golf ball at rest will therefore remain still until struck by the golf club. Mass is a measure of inertia. Objects with a greater mass are harder to change in motion. Net force, the combined effect of all forces acting on an object, is what causes a motion to change. Newton's second law states that force equals mass times acceleration, or that acceleration equals force divided by mass. When the club strikes the ball, the net force is applied. The force causes the ball to accelerate following Newton's second law because the golf ball has a very small mass and it can be accelerated quite easily. However, the force between the club and the ball is not one-sided. According to Newton's third law, for every action force, there's an equal and opposite reaction force. When the club exerts a force on the ball, the ball simultaneously exerts an equal force back onto the club.
Momentum is a measure of an object's motion and is defined as the product of mass and velocity. Before impact, the golf ball is at rest and therefore has zero momentum. After being struck by the club, the ball gains a large velocity, meaning its momentum increases significantly. The change in momentum of the ball is caused by impulse. Impulse is defined as the product of the net force applied and the time interval over which it acts. Impulse is also equal to the change in momentum. This means that the force applied to the ball depends on both how large the force is and how long the club stays in contact with the ball. During a golf swing, the club and the ball are in contact for only a few milliseconds. However, increasing the contact time increases the impulse delivered to the ball. A greater impulse produces a larger change in momentum, which results in a higher launch speed. This is why it's beneficial to follow through with your swing. It increases the time the club is in contact with the ball, allowing for a greater impulse and resulting in a higher launch speed. Momentum is also conserved. The law of conservation of momentum states that in the absence of external forces, the total momentum of a system remains unchanged. In regards to the club golf ball system, the momentum before collision is equal to the momentum after collision. Collisions can be classified as elastic or inelastic. Elastic collisions involve no lasting deformation and no significant generation of heat, while inelastic collisions result in some permanent deformation and/or the production of heat. Work is done when a force moves an object over a distance. It can be defined as work equals force times distance. The SI unit for work is the joule, which is equivalent to 1 Newton meter. Power is the rate at which work is done. It is equal to the amount of work done divided by the time interval. The SI unit for power is the watt, which is equivalent to 1 joule per second. Energy is the capacity to do work and is also measured in joules. In golf, the two main forms of energy we consider are potential energy and kinetic energy. Potential energy is stored due to an object's position. For example, when a golfer raises the club to the top of his backswing, the club has gravitational potential energy, which can be expressed as PE equals mgh, where m is the mass of the club, g is the acceleration due to gravity, and h is the height of the club head above a reference point. Increasing potential energy at the top of the swing allows for more energy to be converted into motion during the downswing, leading to greater kinetic energy at impact and a faster moving ball. Kinetic energy is the energy of motion and depends on the mass and speed of a moving object. It can be written as Ke equals half mass times velocity squared. In golf, both the club and the ball have kinetic energy during the swing and impact. The faster the club head moves, the more kinetic energy it has to transfer to the ball. Because kinetic energy depends on the square velocity, even a small increase in the swing speed can significantly increase the ball's speed and range. In a nearly elastic collision, most of this kinetic energy is transferred from the club to the ball. According to the law of conservation of energy, energy cannot be created nor destroyed, only transferred or converted into other forms. In golf, energy can be transferred into less desirable ways due to friction, off-center hits, and poor swing mechanics, reducing the energy delivered to the ball. During the golf swing, the golfer does work on the club by applying force over the distance of the swing. This work increases the club's kinetic energy, which is then transferred to the ball during impact. Maximizing performance involves 1. Increasing the backswing height to increase potential energy, 2. Swinging the club smoothly and quickly to increase kinetic energy, and 3. Maintaining proper technique and follow-through to ensure energy is efficiently transferred to the ball. Factors such as foot placement, stance, and balance also play an important role in maximizing energy transfer.